Bienvenidos, Ushamdi, and welcome CTS-131 Section 875 students for the spring 2018 semester at Anne Arundel Community College. This is the Routing and Switching Essentials version 6 course, and this morning's Packet Tracer tutorial and solution set is going to be on Packet Tracer activity 1.1.4.5, where we're going to be configuring and verifying a small network setup. So let's go ahead and jump into this Packet Tracer activity. And you can see, definitely a small network. We have a router here, and we've got two distinct /24 networks that we're going to be working with. So here's our addressing table. We should be familiar with this right now. We've got all of our VLAN information in here, as well as PC1 and PC2's information. And so we're going to configure devices, verify connectivity, and gather some information with show commands. So let's go ahead and start. We're going to configure switch 1 with remote management and configure the PC. So nothing on switch 2, it doesn't look like right now. We've got some passwords here, right? User exec is Cisco, and the privilege exec password is pass. So part 1, let's jump in on router A. And that's going to be the first thing we configure. And let's give ourselves a little more room with which to work here. And so we will stretch out router A. So we'll go to the command line where we should get, okay, no password prompt yet. I thought maybe like the previous activity. So we are simply in user exec mode as indicated by the greater than sign. Now we're going to go ahead and configure a host name and a banner and line password set to Cisco, encrypted set to class, IP addressing and descriptions on LAN interfaces. All right, well, let's make that happen. So to get from user exec mode to privilege exec, we use the enable command. And then once we're in privilege exec mode, in order to get into global config, we say configure terminal, or you can simply say conf, C-O-N-F-T. Config T will get us in there as well. So let's go ahead and use the hostname command here. And we're going to say it's router A. And my guess is we get a couple points for that, and we do. And a banner. So is there any indication as to what the banner needs to say? So let's just go ahead and see here. Banner motd, I like to use the %. And we'll stick with the warning message from class. From the previous discussion in class, we'll say warning and authorized users only. And then I will end that with the %. And so we've got the banner added, no points for that, and we'll keep trudging along here and see if they're looking for something specific. We can change it very easily. So line password set to Cisco. Well, if I say do show run, we can see and go to the end here. We've got the console line, we've got the auxiliary line, and then we've got the VTY, or the virtual login line. So I'm simply going to say line con 0, and we'll say password, and they want it set to Cisco. So we do get some points for that, and then we'll say line VTY is 0 to 4. Sometimes it's 0 to 15. Here it's 0 to 4, and we'll simply say password Cisco. So this looks very familiar. It should look very familiar based off that discussion question we had starting the first week of the class as to how to configure a router, some of the basic commands. Now we're going to do the exit command here to get back to global config, where we're going to set the encrypted password, and it's really the enable password, right? So encrypted password set to class. So enable is, my guess is what they're looking for. Enable, secret, and class. And so we should move up from 8 points to 11. So this was a little cryptic here, no pun intended, where it said encrypted password set to class. And they're talking about the enable password. So let's go ahead and do some IP addressing and descriptions on our LAN interfaces. So I'm going to say, whoops, come back over here. Let's get back in the right window. Let's go into interface gigabit Ethernet 00 to start out with, and we'll say no shut so that we can see which interface are we working on. Well, you can clearly see that we're working on this interface here because it was red, but now it's transitioned to green. Now, why is this orange? So think about that for about 30 to 45 seconds, and then see if you can come up with the answer. It's going to go green here in about 30 seconds, so pay close attention to that. But we'll work here while this is doing its thing. So we've got the interface in the up mode. We'll put a description here, and I'll just say interface to LAN, and we'll just say PC1 is what we'll call it. Now let's get our IP address on here. So 10.10.10.1, and this is a /24. So we've taken a class A address and we've subnetted it down to a /24. You'll notice I'm not going to say that we subnet it to a class C, because that is not what we're doing. Remember, the class is inextricably linked to the value in the first octet. So we've taken a class A address and we've subnetted that to a /24, or we've borrowed 16 bits from the host portion of that address and made it network centric. So we've got a /24. All right, and so we've got our description on there. Let's do the same thing for gig, and actually I'll tell you what, we'll do one side at a time. So now let's come over to PC1. You can see we've got some information to enter in here. Now, based off the fact that I just told you that it's a class A address, when I type in 10.10.10.10, whoops, 10.10.10.10, when I hit the tab key into the subnet mask field, what value are we going to be expecting? Is it going to be 255, 255, 255, 0, a /24, or is it going to be in line with what a class A default subnet mask would be? And there you have your answer. Just like we saw in the previous activity when we were working with 172.16s, which are class B addresses, these are class A's, and so it defaults out. And that's why you see that value in there. We need to come in here and make that change. Now, the default gateway, remember the default gateway, we need to get to a router as our default gateway, and that's going to be 10.10.10.1, and no DNS information given, so we'll leave that blank. No IPv6 information given, so we're not going to be doing anything down here with IPv6. So now I can close this out. Let's bring the command line prompt up. Can I ping my default gateway? Probably one of the first tests you're going to do. And we can. Fantastic. So the top half of our network seems to be functioning, right? I can go from PC1 through switch 1 over to router A. But let's go ahead and bring router A back up and do the bottom half. So interface gigabit Ethernet 01. I'm going to say no shut. And again, and I won't forget this, I'll be sure to cover this. Why is that orange, do you think? This is green immediately, but this is orange. And let me configure this here, and then we'll talk about that. So we say no shut. It brings up the router interface. And I'm going to put a quick description on here. And we'll just say LAN interface to PC2. IP address is going to be, and where is that at? Router B, 10.10.20.1 is the default gateway. And again, we've subnetted a class A address down to a /24. So we've got that sorted out. Now, these lights are green, but they were orange. Why were they orange? What do you think? Exactly. Because on the switch, right on the switch side, the interface was down on the router and the switch side is down. When it comes up on the switch side, it has to go through the different spanning tree states before it goes to the forwarding spanning tree state. So in other words, it was down, and then it had to go through the listening state, and then the learning state, and then it transitions to the forwarding state. And listening and learning are both right around 15 seconds, and that's why you're going to be waiting about 30 to 45 seconds for that interface to come up, and that's why it was flashing orange. And as we move through the course, you'll find out a lot more about spanning tree, but that's why that's orange. Okay, so we've got that interface configured now to PC2. We'll pull the desktop up, we'll bring the config up, and we'll say 10.10.20.10. And again, we get that 255.0.0.0, which is not what we want. We're subnetted here. And our default gateway is the address on the 10.10.20.1, the address on the router A interface that we configured. And so now let's bring that down and let's pull up the command prompt here. And can I ping 10.10.20.1, my default gateway? Absolutely. So if I can get to the router who knows about the network on the upper half of this topology, the 10-10-10 network, can I ping 10-10-10-10? Absolutely. So I've got connectivity all the way through. And so let's see here. Oh, let's save the configuration on router A. Excuse me. So we save the config. All right, using the addressing table for PC1 and PC2, we did, and configure switch 1 for remote management. Now, this is a phenomenal activity. I'm so glad that they've introduced this as early as they have, because this is one of the most confusing aspects of the statement that's going to be required here in step B. And so we're going to cover this in depth. And my guess is, I don't know if we're going to get 60 or 55 points for these two things. We'll see what happens. So using the addressing table, let me go back here. Did we do everything? Yeah, everything's configured. All right, I'm just kind of dubious that I'm skeptical that we're going to be getting 55 points for these two tasks, but we'll see how, or I'm sorry, for these three tasks, but we'll see how that works out. All right, use the addressing table, configure the management interface for switch 1. Now, there's a couple subtle things that are happening here, and unfortunately, the type here, the font size is going to be absolutely tiny. And it's something with packet tracer. I'm not sure what it is. Oh, okay, great. It looks like they fixed it. In the previous version of packet tracer, if you watch any of my videos from the fall 2017 CCNA course, the switch font, no matter what you did with the switch font, it was tiny, very, very small. So they fixed that, and I'm very glad that that's been fixed. All right, so the line password should be Cisco, and there we go. So now we're into user exec mode on the switch, as evidenced by the greater than sign. We type EN or enable to get into privilege exec, where we have to say class. And the hash sign tells us that we are in privilege exec mode. And it's from here that I can get into global config. All right, now let me look at this. Use the addressing table to configure. So do show IP interface brief. Now you see we have all these interfaces here, right? Starting with fast Ethernet 01, so it's probably a 24 port switch. It is. And we've got VLAN 1. And you can see that VLAN 1 is down. Now, by default, on a layer 2 Cisco switch, and on multi-layer switches as well, by default, the only VLAN that you have after you take that switch out of the box and you plug it into the wall and you terminal in or you console in, the only VLAN on that switch is VLAN 1. Now, a couple quick things. This activity, and I know why they don't introduce this yet, because we haven't talked about creating different VLANs or inter-VLAN routing. And that's why we're going to be working with VLAN 1. But I want to give a quick note here that you should never use VLAN 1, right? VLAN 1 should be shut down like it is here, and it should not be used in a production setting. Now, we're not to that point yet in the course. We will be soon, right? So for right now, we're going to suspend reality and what you would do realistically, and we're going to go with this VLAN 1 configuration. But in reality, you don't use VLAN 1 for anything. And there are a whole host of reasons for that, which we will get into down the road. So for right now, we will use VLAN 1, and that is going to be where we configure, and you can see here, it actually shows switch 1 and switch 2. I think we're only configuring switch 1 though. And you can see here, it gives us that VLAN 1 management information, because right now, every port on this switch is in the same broadcast domain, in the same subnet, i.e., in the same VLAN, which is VLAN 1, which is why you can take a Cisco switch right out of the box, plug all of your stuff into that same Cisco switch, and everything will be able to communicate as long as it is on the same subnet. So here we go. We're in global config. I'm going to say interface VLAN 1, VLAN 1, because we're going into the layer 3 switched virtual interface. This is a software interface. It's not a hardware interface. It's not on the front of the router somewhere, right? It is a virtual software interface that runs on the router. And so we say interface VLAN 1, and this is where I put in the IP address of 10.10.10. And I'm on switch 1, 10.10.10.2, right? And I need my dotted decimal notation subnet mask that we subnetted down to a /24. And we've got that information in there, right? And it's administratively down. So I need to say no shut. I need to bring that interface up, and we are still only at 50 points. Well, this is going to be interesting. So we're still only at 50 points, and the interface is up. So if what I just told you is true, that it's now on this network, I should be able to come to PC1 and say ping 10.10.10.2. And I should be able to ping the switch, but we can't. And now we can. There we go. Remember, so the PC said, hey, I don't have an entry for this in my ARP cache, right? And it has to ARP out. That's probably why we get the request time out. It's got to learn that layer 2 information before it can successfully ping at layer 3. So now we get down to this, and I wouldn't be surprised if they gave you 50 points for this. I'm doubtful, but we'll see. So configure the default gateway address. Now, this is where learners become very, very confused, because you're told configure a default gateway address here. And you immediately think to yourself, wait a second, I just configured the PC, and what was the default gateway address I put on the PC? It wasn't the switch. I put the router as the default gateway address. And this is where the confusion comes in. So let me go ahead and walk through this. On the PC, we specify the default gateway as the router's interface, because the router knows how to route between these two networks, because it's only the router who knows about the 10.10.10.10 and the 10.10.20.10. The switch doesn't know about this network here, just like switch 1 doesn't know about that network. Switch 2 has no idea what's going on with that network. And it's the same thing. The PCs don't know about this network, or PC1 doesn't know about the 10.10.20, and PC2 doesn't know about the 10.10.10, right? Only the router knows about both networks. So again, why am I being asked to put a default gateway address on the switch? Because the switch is not capable of routing packets at layer 3. This is a pure layer 2 switch. So it's not capable of routing traffic at layer 3. So why am I being asked to put a default gateway here? And this is why. Because the switch, in addition to allowing other hosts to plug into it, right, and other routers could plug into it as well, in addition to allowing other devices, other hosts, nodes on the network to plug into the switch is itself a node on the network. And it is conceivable, and that's what we're going to be doing here, that we would want to remotely connect to switch 1. And if that's what we wanted to do from, say, PC2, or even from switch 2, switch 1 has to know what its default gateway is. So in this context, when you're being asked to configure a default gateway on a switch that is a layer 2 device, and we're talking about it in the context of remote management, in other words, i.e. coming from PC2 who is remotely connecting, who is not going to be connecting from the same network, i.e. PC1, PC2's connection would come this way. Well, once it gets to switch 1, switch 1's going to say, oh, great, I see a connection coming in from 10, 10, 20, 10. And switch 1's going to say, so now I need to send the traffic back to that IP address, which switch 1 has no idea how to get to it. So in this context, when you're being asked to configure default gateways on switches, it's not because the switch is routing PC1's traffic. It's because the switch needs to route its own management traffic. It needs to know where the default gateway is for management plane traffic. And that could also be if I was to ping and generate the ping on switch 1 over to PC2, or generate a trace route from switch 1 over to PC2 to a network that the switch does not know about. So we're basically treating the switch as if it was simply another host by assigning it a default gateway address. And that is why we put it on there. But again, this becomes extremely confusing for learners who see this and they think, oh, I'm setting up routing for transit traffic. In other words, for traffic coming from PC1, people get confused and they think, oh, I'm configuring the default gateway. I need to tell the PC1 traffic, oh, you go here. Well, no, that makes no sense. Think about it. We've already told PC1 what its default gateway is. When we put the IP configuration on PC1, we said 10.10.10.1 right here. So we don't then need to do it again. We're simply doing it for the switch's traffic that it is generating. Transit traffic, which is traffic that passes through the switch, is not affected by the IP default gateway statement that we're getting ready to put here on switch 1, right? So again, you may want to re-listen to that explanation because it definitely causes confusion when learners see that and they think, oh, well, I can just go ahead and put the IP default gateway 10.10.10.1, I can put that on the switch and it will route PC1's traffic over to PC2. And so again, so before I do this, let's take a look. Can I ping 10.10.20 and what is it, .10? Can I ping from PC1 to PC2? I can, right? And it works. So let's put the IP default gateway on switch 1. And now, and actually, let's do this. So we'll test that it works from PC1 to PC2. If I remove that and I say ping, and I'm on switch 1 right here. If I say ping 10.10.20.10, which is PC2, is this going to work? And no, it won't work because I need to get the right syntax in there. But when I say do ping 10.10.20.10, it doesn't work. Why does that not work right now, but this from the PC works? And again, this is where it gets sometimes a little murky. We put the default gateway on the PC. It knows where to go for traffic that is not on its subnet. It knows to go to router A because, again, router A knows about both of those networks. So that ping command is going to work. But what about the switch? This isn't traffic passing through the switch. This is traffic being generated, management plane traffic. Because right now when I type that command, the switch says, well, I've got the VLAN 1 entry. I know about 10.10.10.0/24, but I have no clue how to get to 10.10.20. So just like the PC, if I was to come onto the PC and come here and say, yeah, we're going to get rid of the default gateway. Now let's see how this works. Does that work with no default gateway? No, it's not going to. Because the PC right now says, okay, I know that this isn't on my local network segment, so I need to send it to a default gateway. But guess what? We just stripped that out. There is no default gateway. So the PC is behaving just like the switch, right? Because the switch, this is traffic being generated from the switch, just like this is traffic being generated on or from the PC trying to get to a network they don't know about. So in other words, they both need an assist. They both need a little help here. They both need what? They both need to know the default gateway, 10.10.10.1. And now, now when we rerun this, it works. And so as you can see, the switch is having the same problem that the PC was having. It doesn't know because this is traffic. The switch is just acting like a host right now. He's just another node on the network. We're not talking about traffic that is transiting or going through. And I'm going to define going through like this. It enters one side of the switch and exits the other side. That is transit traffic. That is not the traffic I'm talking about. I'm talking about traffic being generated on or in the switch. Sorry, I went the wrong direction there. Management plane traffic being generated in the switch, going somewhere that is not on a network segment that the switch knows about. Remember, it only knows about VLAN 1, and on switch 1, that is only that network segment. So we need to help the switch out. We need to give it a default gateway. And so, let's do this. IP default gateway 10.10.10.1. And again, it's the same router interface because the router, you have to ask yourself, who knows about all of the different networks? The router. So I just need to get the traffic to the router, and then the router can get it to where it needs to go. And that's that default gateway. So now when I say do ping 10.10.20.10, does it work? It does, right? And that solved the problem. So for management plane traffic on the switch, traffic being generated by the switch, not transiting through the switch, this works. And I'm going to prove it one last time. That command right there, IP default gateway 10.10.10.10, has nothing to do with the PC's traffic getting to the default gateway. And here's what we're going to do on the PC one last time. Let's do this. Does the PC work right now? Yeah, it still works. It still works. But what if I do this? What if I take that away? And again, the thinking here would be, oh, well, I just put the IP default gateway command on the switch, so the traffic will know how to get to the switch will route it to the router. And that is not the case. Take a look. It's not going to work. Because again, that IP default gateway command on a layer 2 switch, and you should only see that command on layer 2 switches. If it's a multi-layer switch, which we'll get to, that would route the traffic. This is a layer 2 switch. It is not doing any inter-VLAN routing. And so as you can see right here, I just proved that even with the IP default gateway command here on the switch, it is locally significant to the switch. The PC, it doesn't make a difference. The PC's broke because, again, we need to tell the PC that your default gateway is 10.10.10.1. I need to get you to that router, right? And then when we come back and can we ping over to PC2, we can, and it works. But again, I wanted to spend a significant amount of time on step 3 because this configure the default gateway address for learners new to routing and switching always causes significant confusion. So let's save our config. Let's say end and then write mem. So we actually picked up and actually copy running config. Is it looking for that or copy running config startup config? We got 2 points for that. Okay. So gather information with the show commands. So issue the following commands and then answer the related questions. So we'll walk through this. I'm going to scooch all the way down here. Okay, so part 2 is basically just running commands. So it's possible then we may not see those 5 points. And we'll walk through this and see what happens. So issue the following commands, and what they want this to show IP interface brief. Which commands display the status of the port? So here, we'll do it from the router. So we'll get into privilege exec mode here. So I'm going to say show IP interface brief, interface brief. And does that show me the status of the port? Right? It does, right? Because here's the status. What about show interfaces? Does this show me the status of the port? It does. Port is up, line protocol is up. What about show IP interfaces? Show IP interfaces. Does that show me the status of the port? It does. So all 3 of those commands will show me the status of the port. Which command shows only the IP address? No subnet mask or prefix. Show IP interface brief, right? Because the other 2, that showed the prefix. This shows just the IP address. That showed the prefix, and what did we see here? That showed the prefix, right? So only show IP interface brief gives me just the IP address. No subnet mask or prefix. Which command displays the description configured on the interface? Well, it's not show IP interface brief. Do we see the description here? Under show IP interface? Not necessarily. Do we see it here? We do. So show interfaces will show me the description. Which command displays the IP broadcast address? Do we see that with show interfaces, or is it going to be show IP interfaces will show me the broadcast address? What command displays the MAC address of the interface? That's going to be show interfaces, and you can see right here, Ethernet address is that BIA stands for burned in address. That is the burned in layer 2 MAC address. Now, gather information from the show IP route command. So show IP route. And this is why the router, you can see, it's directly connected. He knows about the 10.10.10. He knows about the 10.10.20. And he also has local entries for the address that's configured. These are local host entries for the address that we configured on these interfaces, gig 00 and gig 01. That is why they are /32s, and those are referred to as host addresses. When all of the bits are dedicated. Okay, and then show IP route connected, show IP route connected, and this is another really good command. This shows me just the directly connected, because if there was a static route, which we'll get into soon, I could say show IP route, whoops, not STQ, but show IP route static, and that command actually will work. All right, show IP route connected, show IP route static. That will actually work if I get the command typed in right. How many networks are known by the router based on the command output of show IP route? Well, we know it's 2. What does the L at the beginning of the routing table represent? It's local. What does the /32 indicate? A host route for that specific IP address. So gather information after an interface state has changed. So let's get into global config. Interface, what do they want us to do here? Gig 00, and they want us to shut that interface down. So now let's say do show IP route connected. And again, the interface is down. We only see the single entry. And now we'll say do show IP interface brief. And you can see it shows administratively down. And so the status is layer 1. We're administratively down at the physical layer. At layer 2, the MAC address layer, right? We are down. And did the routing table repopulate? Do show IP route. It did, right? It updated. It got rid of the 10.10.10 network. And what can be inferred about the interface status of routes that appear in the routing table is that if the interface is down, we don't want the router to think that he knows how to get there because the interface is down, right? He doesn't because he can't. So we pull that route out of the routing table, and that ensures that we don't have traffic sort of floating around the network, going to and having the router route packets for a network that it can't physically get to at this point. We would need to say no shut to bring that back up. And again, we've got that orange, right? Remember that. Listening state, learning state, and then it's going to transition to the forwarding state. That's a spanning tree, layer 2 thing that we see going on there. All right, so we are at 55. I am very curious as to what it is I didn't do or typoed. And okay, it wanted a banner message. I did not see that. Did it say that somewhere? I think I went right by that probably. Save the config. All right, so I don't see it telling me to put a banner here. Okay, so that we did. Oh, host name and banner. Man, I need to probably wear my glasses when I'm doing these activities. So it's the banner that we left off. So banner motd, and let's just say warning. All right, and then the login on the line. Did I not? Oops, sorry. Do show run. I thought we did this. And I think they're looking for it on the console line. I left this off. Line con 0. Log in. Was that it? That got me to 58. I'm still missing something here. So hostname and banner. And we did that. And the login is set. Could they possibly want that on the auxiliary lines? And this would be an interesting one. Let's see if they want password Cisco, because the auxiliary lines are used for like a modem. And that is clearly not it. All right, so troubleshooting comes into play here. Let's take a look here, and what is it? They don't like the banner motd on router A. Even though we put it there, they don't like what we put there. Okay. All right, so we've got the banner, and it doesn't like our banner. So let's see what we got here. Let's see if I log out. The banner shows up, so they don't like it though. So let's go ahead and do this. Password would be, is it Cisco? Yep, and let's go into privilege exec with class. And let's go back into global config, banner motd, and I'm going to do it like, instead of doing it like I just did it, I'll do it like this. Whoops, sorry. We'll do it like this. I'll make it a multi-line. This is your banner. Let's see if they want it multi-line. Is that what it was looking for? So I don't see it saying what the banner should be. We're clearly putting the banner here, and it's not taking it. And let's see, copy, running config, startup config. So it's something to do with the banner. Let's see if, it says it's on router A, but let's see here. And you know what it might be? Banner motd warning. Are they looking for it on the switch? And they are not. Okay, so it's something with the banner, and this may be a bug here. Router A banner motd incorrect. And that is certainly what we're missing out on here. So let me do this. We're going to reload router A. Let's save our config. And let's reload the router. And you can see we lost 24, 22 points there. So the router will come back up. And it's possible this is a packet tracer bug, because there's my banner. It clearly shows it's there. And let's see. So we've got that. Let's get into privilege exec, Cisco, class, and global config. And let me see if they want login. Maybe it's the login banner that they want. Warning. Was that it? It doesn't seem to like that either. All right, well, this is definitely has to be some sort of a bug. So we've got the login banner in there. We've got the motd banner in there. And it is simply not going to give us the points. It could be a version issue with Packet Tracer because, again, on router A, we clearly have the banner motd and banner login set. So if you end up with 58 out of 60, don't worry. I will look to make sure that the banner is set, and as long as you've got it set, you're good for all 60 points. All right. Well, that is it. That is going to wrap up Packet Tracer activity 1.1.4.5, where we configured a small network and we verified some things, and we went overboard there on the motd. But it looks like maybe the most recent version of Packet Tracer isn't compatible there. So that is okay, as long as we get that banner motd in there. All right, thanks for watching, and I will talk with you soon.